Okay, so for Allegheny campus, nursing 130, a lot of your test is very similar to the test you had last semester. Um, I don't know definitively if it's a paper test or a blackboard test. Historically, it's been a paper test. But I know that I think they are transitioning to doing more of the blackboard tests, which is what you took for 110. But I'll help prepare you for whichever version it is. You still have to know how to do the math. Most of the stuff is the same. You're going to be doing some metric to metric and metric to household or household to metric conversions. You're going to be converting pounds to kilograms. You're going to have your intake output calculation, which is that urine question where you calculate like how much water you are going to give the patient after they've voided a certain amount. So we'll look at those. You're going to do your oral based meds and your parenteral meds, which are kind of going to be calculated the same. So remember, capsules, milliliters are pretty much the big things that you're calculating for with your oral medications, and then your parenteral medications is just mLs, unless it's insulin, and then it's units, which is the next thing. Insulin dosages, including mixing of insulins. Um, then you're going to have, which is new for you this semester, is these IV therapy flow rate calculations. So I'll spend a little bit more time on those because that is new for you guys this semester, where you're going to be calculating ml per hour as well as drops per minute. Um, and then you'll have a few reconstitution questions and then some more multi-step type questions, and I'll explain what those are as we kind of progress along. So let me go ahead and get right into it. Change my window that I'm sharing. All right. So this is the same review that I've shared and posted over the years. It's in the shared um, OneDrive folder. And so a lot of the questions are the same. A lot of times, what I do during my reviews is I'll update the question, just change a few numbers just to make sure um, you're good and you have it, have it established of what you're supposed to know. But I'm going to go right into kind of the new stuff. I'll come back, and if we need to touch on these, I'll touch on these, but I want to spend most, or at least start off with like kind of the new stuff, because hopefully this is something that like you might be rusty on, but you know how to solve it. I know you know how to solve it because you did it to get through 110. The difference is your test is next week, and you gotta focus now and on getting this stuff down. Number six is always a challenging question, so I'll make sure that we come back to that as well. But what I want to do is I want to kind of scroll down here to the flow rate questions, because those are things that are a little bit different than what you've seen before. So I'm not going to start off with number 16. I'm actually going to start off with number 19, and I'm going to kind of jump around a little bit, and there's a reason for that. Okay. So let me open this question up a little bit. So the reason I like to start with this question specifically is because I like to use this as a way to kind of introduce flow rates. So flow rate just means we have some sort of volume, which is typically milliliters, over some sort of time, which is typically hours. Okay. Now that's not always the flow rate, but that's the typical. It's the some volume over some time, and it's typically milliliters per hour. And what the nursing department wants you to be able to do is use that information in order to find different things. The first thing is, what would you program into the infusion pump? What would you set on, the patient's infusion pump, and can you set it correctly based off of the parameters? I'll add this caveat, and you'll hear me say this throughout the next couple of semesters. Um, what we talk about here in the math world may not be directly correlated to what's happening in the real world. So what you see here, like the way we can set the infusion pump and all that kind of stuff, there might be different limitations that I'm not accounting for when I kind of create these problems. And these problems are also just been created by other nursing practitioners. So there is some real world kind of correlation basically in the math part, how to solve it. But like, let's say you get an answer of like, 23.3, milliliters per hour, but you can only set the infusion pump to 20 or 25. Well, then in that situation, you're going to follow whatever orders you're supposed to follow, or it might just be a bad mathematical setup. You might notice that like when a doctor prescribes like a medication, nobody's ever taking like or having to decide, do I take a half a capsule or do I like pour like, do I round up like the capsule? It's usually like, you know, 250 milligrams twice a day, and it's available in 125 milligram capsules. And then it's just two capsules twice a day. It's usually not like it works out. That's typically how that works. From at least I know that from working in a pharmaceutical or a pharmacy as a pharmacy tech. But um, with flow rates and things like that, there's some things I just don't have like a solid thing on. So if you see some discrepancies or you've seen things in the hospital and like, oh yeah, I couldn't program the infusion pump for that anyways, just remember you're in the math bubble and it's more about can you get to the calculations, and they're trying to trick you a little bit, but not so much. It's not at least it's not an intentional trying to trick you. Just want to make sure they you know to solve it. So a lot of times this question, believe it or not, number 19 gets missed because students are looking for something to do math wise when all you have to do is set the volume over the time. And as soon as you do that and you see this and you go, oh, okay, I think I know what to do with that. I can just reduce 375 over 3, and then you get your answer is 125 milliliters per hour. It is that easy. It's not supposed to be any more difficult than that. It just like seems like it should be more challenging, but that's what that is. So like as a challenge, I'm going to give you just an alternative thing, and you can actually solve this, type your answer into the chat once you get it. And so basically what I'm going to give you is the volume and the time. And then so I'm going to say, let's say it's they're getting 500 milliliters and then in 2 hours. So my question is for you, what would you program into the infusion pump so that they get 500 milliliters in 2 hours? And like I said, just type it into the chat. Good. Yeah, good. Okay. Yeah. So hopefully, and I'm seeing your answers, most everyone that's typing there pretty quickly, 250 milliliters per hour. Okay. You just need to reduce it. I know that's very straightforward and easy. Um, and that's what we want it to be. We want these things to be easy. And we start off with the easy stuff because this is the things that like when you get stuck on something, how do you simplify it? How do I make this look easy? That's the goal here. Okay. Now, what about something like number 20? I'm sorry, not number 20. What about something like number 17? So I'm going to scroll up a little bit, create a little bit more space here. So number 17, actually, now we're doing something here where we have minutes involved, and the minutes really is something that throws a lot of students off. So you can see that there's a volume and there's a time, but the time we're looking for is actually in hours. So you either need to convert minutes to hours, which you can do, or you need to know how to manipulate the numbers in order to get to the answer you want. So either way, I pretty much just said the same thing. I would say like the thing that I immediately do is I sit there and I say 90 minutes, that's the same thing as 1.5 hours. And if you're like me and you do that, then you just take the 120 ml over the 1.5 hour, and then it looks like we get 80 ml per hour. Now, here's the thing. A lot of students get stuck on this question because they're like, wait a second, it says to give them 120 milliliters. Why am I only setting it to 80? Well, because after 90 minutes, they will have received 120 milliliters, 80 the first hour, and then 40 in the next half hour. 80 plus 40 is 120. That's how you kind of do that. Now, let's say, what if you get a question that it's not as easy as 90 minutes, which is 1.5 hours? The other way you can solve this is by taking the volume over that original time, and this skill is going to be helpful later on down the road, and even into your third semester, and then just setting up a conversion where you convert minutes to hours. And you just have to remind yourself, okay, well, in 1 hour, there are 60 minutes. And then all you do here is multiply across the top, 120 times 60 divided by 90, and you're going to get the same answer, which is 80 milliliters per hour. So just like last time, let me give you another scenario and see how you do with it. So let's say I'm always kind of doing these in my head. So let's just say it's 150 milliliters in let's say 40 minutes. Okay. Okay. So the answer I'm getting is 225 milliliters per hour. If you're not seeing that, that's why I'm here trying to show you. So if I'm setting this up, you may not know that 40 minutes is 2/3 of an hour. And then if you were to convert that into a fraction and it's like 0.333333, don't do that. You're adding an extra layer of struggle that you don't need. So what we're going to do is the same thing I did over here, where I'm going to take my volume over my time, and then I'm just going to convert my time. I'm not going to do anything with the volume. Volume's good. I'm going to convert my time into hours. And again, 1 hour, 60 minutes. We know we've done everything right because we're in the units we want to be in before we do any kind of math. 150 times 60, I think it comes out to 9,000 divided by 40 is 225 ml per hour. Go ahead, Mackenzie.
So I did get that answer, like the 225 per hour. But like if the order says 150 in 40 minutes and we set it to 225 per hour, they're gonna get 225, right?
Good question. So, no, because there's only 150 milliliters available for them to receive. So, like, think of it this way, like, because a lot of times when you see these numbers, you're sitting there going like, "Oh man, that seems like not much here. That seems like that's going to be like real like or the volumes seem weird because the numbers are big with the mLs. It will take you probably less than 5 seconds to drink down 150 milliliters, no problem. But if I want you to sip it for 40 minutes and then I want to artificially like program into like some sort of pump that it's going in and trickling in, that's kind of what's happening here. So there's 150 milliliters in the IV or in the tube feeding, but you still have to set it to the correct setting per hour because in this scenario, there's no like minutes like setting. Does
Okay.
that make sense?
Yeah, I just sometimes when I do those questions and I get like the 225, I'm like, that doesn't make sense.
Yeah, what did
But
I
we're
do
just
wrong?
we're just assuming that the bag itself is 150.
Right, because
Okay.
remember, the other thing, and you're right, the other thing is it's only going to run for 40 minutes. Okay.
Okay.
So even though you set it for 225 ml per hour, there's only enough liquid to run for 40 minutes.
Okay.
Yeah. It makes, and that's the reason why I gave you the 40-minute challenge because exactly that. I'm glad that you asked your question because you're going to sit there and go, well, that doesn't seem right. How can I give them more than what was ordered? You're not giving them more than what was ordered. You're setting a rate. The other example I give is a rate is just like, how fast you're going, right? So if I want to go from point A to point B, it's 35 miles per hour. It's going to take me, X amount of time to travel at 35 miles per hour. Can I get there quicker? I can go 45. I can go 60, right? So you can get there quicker and still, and even though you're covering the same distance. And that's kind of how I look at the flow rate as well as this. And you're not going to get many questions. You might get one question, and my guess is that they'll do more like the 90 minutes or the 120 minutes. So, quite that approach. So, great question. Thank you for asking that. Um, okay. The next thing about flow rate is being able to apply your knowledge. So this is kind of like a reverse of what we were just doing. So the challenge is how do you convert minutes to hours? You're doing that just fine. Trust your answers, rework the question. And it is okay if your number is bigger or smaller than the order, because when minutes are involved, that's kind of what manipulates that. The other thing is, let's say I know a volume, like I know how much I'm administering or how much is there, and I want to know how long it'll last. Okay. In order to solve that, I have to know the flow rate. So what we're doing is we know the volume, 500 milliliters. We don't know the time, but we know that it would give us 125 milliliters per hour. Now, this is not helpful, I don't think, for like how I would set up this particular type of question, but I'm just trying to write out visually what you are what you're being asked. Okay. So we want to know, what is this time? We want to know, what is this hour or minute or whatever this happens to be? How long is this running for? So there's a couple ways to do this. Following dimensional analysis, I would start off with my original volume, 500 milliliters, and then I would just convert milliliters to hours. And how do I do that? With my flow rate. So I'm dividing by 125 milliliters. And when I do that, and I see some of you are starting to write down the answer, I get 4 hours. So the trick to this is, and this is where they're stepping up some of the things, some of the questions as far as like, um, based on, compared to what you did in 110, that they're asking you to step up your knowledge and be able to, um, gain information from this. Now, most students that I talk to who like either don't do dimensional analysis in the classical way, like I'm showing you, or they get it a different way. They just they take the total, divide by 125, and then they get their answer. And that's all I did. So don't think I'm doing anything differently. The challenge is to make sure you know how to calculate hours when they give it to you. Let's try another scenario. Um, what if I'm starting off with 600 milliliters for my IV, and it's infusing at um this might not work out at all, but let's say uh let's just say 200 ml per hour. How much time will it take for that to run if it's running at 200 milliliters per hour? Good. Okay. Yeah. So I'm making some of these intentionally easy, but if you ever get stuck, this is how you would solve it using dimensional analysis. Okay. All right. The next thing to talk about are flow rate. Or we've been talking about flow rate, drop rate. Um, and so what's happening with drop rate? Just wanted to see if I can get this to, that's fine. What's happening with drop rate is we're manipulating flow rate in order to get a different time and a different volume and a different time. With drop rate, we're looking for drops per minute. So how do I get to drops per minute? So there is a formula that's in like the intro part of these practice sheets, but it looks like this. I'm going to take my flow rate times something called the drop factor, and that'll give me my drop rate. The flow rate is almost always in milliliters per hour, but it could also be in milliliters per minute. So let's just say or minute. Drop factor is always given to you, and the drop factor is drops per ml. So here, this is where the drop factor is given to you. It's on a label or to be written for you. On ATI, they might ask you to calculate a drop rate, or maybe you've already had some of these questions, and they say you're using microtubing. If it says the word microtubing, that's 60 drops per mil. That seems to be the standard. We don't have you memorize 60 drops per mil, mainly because obviously you can see here's an example where it's 15. I've seen 5, I've seen 10, I've seen 30, I've seen 45. There's a variety of different drops per milliliter. It depends on the diameter of the tubing. Your drop rate is always going to be drops per minute. Now, what gets a little bit confusing is that sometimes you can have a very slow infusion. Like if I'm infusing something at 100 milliliters per hour, that's really slow. Technically, it's dripping, and we would actually sometimes refer to it as a drip rate, even though they want you to calculate ml per hour. Ultimately, it just depends on what the question is asking. You're going to run into that more starting next semester into 2230 when you start doing the heparin protocol. Heparin infusions, you need to know how to calculate ml per hour for what they call the heparin drip. So the heparin is dripping. It's a slow rate. It's like, 10 milliliters per hour, but they don't do it as a drop rate. They do it as an infusion rate. So there's a little bit of confusion with that. Just giving you a heads up. But at Allegheny campus, you don't really have to worry about that too much because they always are going to give you what you're calculating for, what you're solving for. So, how would I set this up? I'm going to take so this tells us that we have our drop factor of 15 drops per ml. It tells me I have a volume of 75 and then a time of 25 minutes. So, I'm going to take my 75 ml over my 25 minutes. The rookie mistake would be to convert minutes to hours. And the reason I say that's a rookie mistake is because your final answer's in minutes. So leave it. If it's already in minutes, leave it. The only time you should be converting with these drop rate questions is if you are in hours, and I'll give you an example of that in just a little bit. Um, my drop factor is 15. Now, again, you don't necessarily have to write out everything I'm writing out. Those of you who've worked with me before, or if you've watched any of my YouTube videos, I write these out so I can show you that we're canceling out the things we don't want and we're left with the things that we're looking for. So before I do any math, I know I've set this up right. Unless I put numbers, like I just made up numbers, I've set everything up the right way, the way it's supposed to be. And then I can just do my calculation. 75 divided by 25 is 3 times 15 would be 45 drops per minute. So I'm going to challenge you and I'm going to give you like something with hours. Let's say this was um, instead of the 75 milliliters in 25 minutes, what if it was 180 milliliters in 3 hours? What would the drop factor or what would the drop rate be if you were infusing 100 milliliters in 3 hours with a drop factor of 15? Tried to trick y'all, but I didn't. So if you took the 180 ml, you can convert right away 3 hours into minutes. So 3 times 60 is just 180 minutes. So those cancel out. And so you're just left with 15. And so your answer would just be 15. And it didn't seem like anyone freaked out about why is it 15? Because that's just what it is. That's how the math works out. And remember, this is 15 drops per minute. So it's like, they're dropping. That's actually dropping pretty slowly, right? If it takes, think about what 15 drops over the course of 1 minute. That's probably painfully slow. Let's look at another drop rate question. I have one right here. So oops, sorry. I'm gonna bring this down to the next screen because I need you to be able to see the drop rate. So I think you're starting to see the pattern here. If you don't recall from last semester, CC equals ML, so you treat them the same. Okay, so it's a 1-to-1 conversion. So it's just more so like if you see that, you're going to take your 1440 over your 12 hours. I can write this times your 10 drops per milliliter. Now, like I said, these are the same. So I didn't actually mean to write that. Now, let's say I'm going to do this like the long way. What I would do is before I solve this, if I'm here and I'm stuck and I can't remember what to do like with those hours, I'm going to convert. I'm going to get rid of hours and convert it to minutes. If you ever get stuck on, do I multiply or do I divide, write it out because in this instance, you want to divide by 60. When we were going from milliliters per minute to milliliters per hour, we want to multiply by 60. If you can just remember, if I want to go to hours, I multiply by 60. If I want to go to minutes, I divide by 60. That's perfectly fine too. It just depends on, you know, how you're setting up your problems. And then I think someone answered, and I think you're right. because I think it's 2, and I think it is 20 drops per minute. When I do this particular problem, what I do is before I even write out 12 hours, I just take the 1440 ml and then I multiply 60 times 12 and I just do that like right off the bat. That way it's just an extra or it's one extra step I don't need to think about because most of all of you already know how to convert hours to minutes, minutes to hours. You don't need to add that extra dimensional analysis step if you don't want it. And then times the 10 and then you get 20. Now, something that might happen, let's say you get an answer of um let's just say it's like 18.45, 45, 45. It just keeps repeating. Can I give somebody a partial drop? I cannot. Yeah, I cannot give somebody a partial drop. So what you're going to do is you're going to look at the tenths place and we're going to round the answer to the nearest tenth. So like, or to the nearest whole number. So if this is zero point 0.4, then I'm just going to leave it at 18. If this was 18 point, 6, 7, 6, sorry, I, um, but if it's something like that, then it's 19. Okay. I have a 12-year-old. That's all I hear at home is 6, 7. Or at least it's starting to wane off. So I hope it's a passing fad. But anyways, so we would round up to 19. Okay. So great question. Is flow rate the same as drop rate? So flow rate just means some volume over some time. Okay. So drop rate is a type of flow rate. But if I'm asking for flow rate, I'm typically asking for ml per hour. And if I ask for drop rate, I'm asking for drops per minute, typically. Okay. Those terms are interchangeable. Like I said, you'll notice it more next semester with your heparin protocol, where they'll ask you to calculate like a flow rate, an infusion rate, and they'll also call it a drip rate or drop rate, even though they're asking you to calculate ml per hour. So flow rate is the same as drop rate. It's just that drop rate is more specific to being drops per minute, if that makes sense. All right. So those are the main like new stuff. Everything else you've kind of seen before. There are a couple of these questions. I'm going to go over them in just a second. That are asking you to do a little bit more like what we call multi-step type questions. So I will go over those. You may have already seen this question before, but the trick to this question is you already know how to calculate the parental calculation. So all you're doing is taking the ml of the 60 milligrams of Visceral, the ml of the 85 milligrams of Mepridine, and then you're just adding the mLs together. So we can come back and we can do that, but I know that these two questions here take a little bit of time, especially this number 23. Um, so I'm going to work through those next because I know that they add a little bit of extra challenge. All right. So number 22 is the Dilantin question, and it's going to talk about a loading dose and then like a regular dosage. Now, the order says that the patient's going to receive 15 milligrams per kilogram. So that means kilogram always in this instance is referencing their body weight of a loading dose by mouth. Then they're going to get 300 milligrams per day. The question says for the loading dose. Okay. So there's technically two doses or two orders here. So like this is order 1 and this is order 2. And we don't care about order 2 because it just wants to know for the loading dose. Okay. How many milligrams? So this is a little bit different too, right? Because you're used to calculating how many tablets, how many capsules, how many mLs. We don't have a label for this particular question. The question is just how many milligrams are you going to give for the loading dose for a patient that weighs 176 pounds? So we cannot assume, or the first step is if I'm in pounds, we need to convert it to kilograms. Okay. So I'm going to take, this is always something worth reviewing. 176 pounds. If you don't recall, this is where dimensional analysis kind of helps out. You should know that 1 kilogram is equal to 2.2 pounds. If you remember that, that'll help to remind you which way to set up or if you're multiplying or dividing. The other way that I always recall or that helps me out is that when we go from the metric system, so if I go from pounds to kilograms, the number gets smaller. And then if we're, and you don't have to worry about this, but if I go from inches to centimeters, the number gets bigger. Okay. So it's just like you get taller and skinnier when you get into the metric system. When that comes up. I mean, obviously nothing's changed. It's just how the numbers line up. All right, so 176 divided by 2.2, I believe that's 80. I'm gonna double check. Yeah, 80. So once I have my 80 kilograms, now I just multiply by my loading dose, which is 15. We're gonna get rid of kilograms, and then whatever 80 times 15 is, and that's 1200 milligrams. So it seems like a lot, right? It's like a big loading dose, but that's why it's called a loading dose. A lot of times you give them a big dose first, and then you kind of then give them a regular like maintenance dose after the fact. Um, in reality, is that a lot of Dilantin? Probably. I don't know like what the actual like dosage recommendations are, or like the safe dosage range and all that kind of stuff. But we're just going off of what this is for this individual patient. Sometimes I get asked like, what about like what if somebody weighs 170 pounds and I'm dividing by 2.2 and I get a number that doesn't equal, it's not even, right? So when I do that, I get 77.27 repeating. So what I typically do and what I've been told is that you would just round this to the nearest tenth and then do your calculation. So that's supposed to be a kilogram, 77.3. I'm going to get 1159.5 milligrams. If you didn't do that rounding, I just want you to know, just so kind of gives you a little bit of peace of mind. If you don't do that rounding, your answer is 1159.09. My assumption is that tenth of a milligram, or that, I'm sorry, 5/10ths of a milligram or half a milligram difference is really negligible and it shouldn't be a problem. Um, and then I always say if you ever run into this situation and you just want to get confirmation, ask your instructor if we convert pounds to kilograms, you want us to round that to the nearest tenth. I think the answer is consistently yes, but each instructor might have a different opinion on that. So just make sure you confirm it with your instructor. If it's me, I'm probably looking at that you got 1159 and the decimal to me is just like a rounding error, but I'm not the one grading your test, so that's why it's important that you ask that question. All right. This one's a doozy. Just because it's just asking you to do multiple conversions. So it says the physician prescribes 500 micrograms of entecavir via nasogastric tubing for a patient with chronic Hep B virus infection. The oral solution contains 0.05 milligrams of entecavir per milliliter. How many milliliters will you administer? So here's the thing. We have micrograms and we have milligrams. We cannot do math when we're in different units. So, I mean, you can, but you're going to add a little extra complication that you probably don't necessarily want to do. And so what I always recommend is either convert milligrams to micrograms or convert micrograms to milligrams. It's really up to you. So just because it's the first thing listed here, I'm just going to go ahead and convert micrograms to milligrams. And I'll show you both ways just so you can kind of see. So how do I do that conversion? Well, you have to remember how many micrograms are in a milligram. So 1 milligram, 1,000 micrograms. And then you're going to get 0.5 milligrams as your order. Now, all I have to do is, again, you can use dimensional analysis, but I'm going to kind of divert from that and I'm going to do ordered over available. My available is the 0.05 milligrams times my quantity, which is 1 ml, and I believe I get 10 milliliters. Let me double check. Okay, yes, thank you. I like the confirmations. I appreciate it. Okay. What if I do it the other way? Obviously, if you've been following along, you know that these things work out the same. But let's take my 0.05 milligrams and let's say I want to convert that to micrograms. So again, if you ever get stuck, do I multiply or divide? Write it out. I know many of you don't care for dimensional analysis. I would agree with you 100%, other than the fact that you have to take this test and pass it every semester. So it's a great tool if you ever struggle or ever get stuck. Okay. So I'm going to multiply by 1,000. I'm going to get 50 milligram or 50 micrograms. And then all I'm going to do is apply that to my order. So 500 micrograms over 50 micrograms times 1 ml, and I get the same answer, 10. Okay. So I said I would go back to the some of the questions, um, the urine replacement volume question, just because I know that's one that sometimes gets missed. I should also add, just like on your Blackboard test, if they ask you to mark the cup, make sure you are marking the cup. So if the answer to this is 30 or 20 or 15, make sure you put a mark on the cup or make sure you highlight a line. A lot of times there's a lot of leeway for your answer. Make sure you definitively, commit to your answer and then select the answer or shade the answer or highlight. If it tells you to circle, if it tells you to draw an arrow, just do the best you can when you're marking. They just want to make sure you can decipher like tick marks on a syringe or on like an injectable on a cup. They want to make sure you can read those things. That's what they're testing you on. Because you can get the math right, but unfortunately miss those questions because you didn't mark the cup. So make sure you do it. All right. For this urine output question. So I've always told students the way I look at this is it's kind of like a ratio proportion, but if you follow the following format, if you take your actual output over your expected output and then times your replacement volume, you will get the answer right every single time. The thing you have to pay attention to is what is the actual output? Okay. So the actual output is 500 milliliters. The expected output is 125. and then the replacement volume is typically pretty consistent. Okay. So if I'm solving for this, I'm just going to take 500 over 125 times 40. Now the reason I bring this up too is just because sometimes what if the urine output is less than the expected volume? You still want to put what actually was voided um, on the top versus what you are basing your replacement volume off of. So in this scenario, we get 160 milliliters. So let's just flip this around a little bit just because I like to make you kind of struggle a little bit and just to kind of reconcile that it's okay to have a number less than what something is. So let's say I have 150 milliliters um, of output um, replace with um, we'll say we'll just say 50, and then the actual output was, let's just say it was 75. So my question is, how much how much would you give them? Okay. Yes, I'm not tricking. I don't think I'm tricking anybody with my questions here. Yeah. Good. Okay. It makes me feel good that so, like, and I know like obviously I'm not speaking to everybody because I can only see who's answering. So there might be some of you going like, I don't know what's going on. But and just so you know, in the future, if there's ever that time where you're like, I don't know what's going on, you can always direct message me. I won't call you out. If you write the wrong answer, I'll say that the answer is wrong and what the answer was, but I won't call you out. I won't say, oh, just make sure there's no uh person with this name on here. Yeah, like uh Tiffany said, like I'm not going to call you out if you send a direct message and just so you can verify. I This is the best place to be wrong with your questions and not know what's going on and then pick my brain to help you answer those questions to the best of my ability. Just so you know that. So those of you who might be looking at this, how do I solve this? Remember, you're always going to put what was actually voided here over what you expect to be the output and then times the replacement volume. Many of you, I think, just did half because that's all I did was half, which is how you got to 25 milliliters. So you're allowed to reason through these things. They're going to ask you to write down questions or write down your work. So you just want to make sure you're writing down the information and showing some sort of work so that they don't think that you like got an advanced copy of the test. I don't know. I don't know how you would, but just in case they thought that. So, um, that's our hour. But are there any questions, any question numbers, anything that I covered that you have some questions on? Now's the perfect time to ask. Go ahead, Mackenzie.
Um, last semester, your like help Zooms were on Wednesday, which is the day I had clinical, so I couldn't go to any of them. But I like did your guides
Hmm.
in 21 and 22. I didn't see any of those questions when I took like the dosage calc course over the summer. So just for like clarification, it's saying like choose the strongest. What is it just like so I
Go
don't have
ahead.
to do all of them. I just pick the one that has the lowest or the highest amount per ml and then calculate it for that. Is that what I have to do?
Yes, that is correct.
Okay.
Yeah, so I doubt or I say I doubt like those questions I've been trying to get rid of because they were just wrongly like kind of added to the practice testing and things like that. Um but yeah, you just like it's gonna ask you choose the strongest concentration. And so the strongest concentration is the one that has the most whatever milligrams per milliliter or whatever, or units per milliliter, whatever it happens to be. Choose the strongest concentration, and then you just do your math based off of that. Um, Reconstitution questions is what you're asking me about. Reconstitution questions will have on the label multiple ways to reconstitute the medication. And so you technically could get multiple answers based off of the way that those questions were originally asked. But when I added in choose the strongest concentration, that was your clue to use the higher number per volume, which is exactly what you're doing.
Okay. Yeah, the reconstitution questions we did were like they were completely different. Like it was asking like how many mLs will you administer if you're reconstituting for like with this amount of reconstitution liquid.
Okay.
Like that's why I was like, I don't know why I'm confused on this.
Right. And the way you were doing it is probably or is most likely more accurate in that all you have to do is it's basically the same thing as an oral based medication. You're just
Yeah.
calculating, or a parenteral medication, you're just calculating how many mLs to administer.
Okay.
Yeah. So I apologize. I think I've been apologizing for the last like 10 years for those questions because I didn't realize like Boyce campus and South campus and I think North campus, they have really good reconstitution questions that we're not using at Allegheny campus just yet. But that doesn't necessarily apply to anybody here, so it doesn't matter to you. But uh, there are better reconstitute questions than those examples. So sorry about that.
No, that's okay. I took my um the dosage calc course at North. So
Okay.
I think that's why I was like a little bit different.
Yeah, I think what she puts together is definitely like, and then her stuff is more geared towards like what they do at North Campus. But you took a really good class, so you did the right thing. Okay. Yeah, someone asked, Jameson asked if the Zoom tomorrow will be the same. Um, so I never know, and I'm not paying attention directly, like who all is coming in here. So I will probably start off and do a lot of the same information. Um, and that the reason being is because I don't know who's new coming into the review session. So yeah, it'll probably be similar. Like I'll start off with the flow rate questions and kind of work through the challenging questions. But if you have a question before I get started, hey, I was here last time. Can you work through this, that, or the other thing? That's great to ask. Or you can, like I said, email me and I'll make sure to cover it. If I didn't cover it today. But the review will be very similar. Yes. Okay. All right. Well, I have the 220-230 class starting up in about 5 minutes. If you are able to join on tomorrow, I'll see you tomorrow. If you have any questions, and for whatever reason, like I said, please email me. So, all right, you're welcome. And if I don't see you, good luck on your test next week. I know you guys will crush it.